Record resolution. Record resolution refers to the level of detail contained within a biological record. The higher the resolution, the more precise the record. For example, a record specific to a date has a higher resolution than a record specific to a year. Now let's look at the four basic components of a biological record and how the information provided for each component can be of a high or a low resolution. For the WHO component, high-resolution data could be information relating to the person or persons that generated the record, such as full names of both the recorder and determiner. Low-resolution data may only credit the record to a group or an organization. For the what component of a biological record, high-resolution data may be a species name or even a subspecies, whereas low-resolution examples include providing only the family or even broader taxonomic classifications such as order or phylum. For the where component, high-resolution data will narrow down the record to a relatively small geographic area, such as a 10 metre by 10 metre or 100 metre by 100 metre grid square. Low-resolution data will be less geographically specific. For example, detailing the record as being located within a 1 km by 1 km or even a 10 km by 10 km grid square. Higher resolution data for the when component would include a full date and possibly even the time of day, or a short date range. Lower resolution records may be recorded to longer date ranges, such as by month or by year. Although higher resolution records are more useful, it is important that data is only recorded to a resolution that the recorder can accurately record to. For example, there would be no point in providing a 10 metre by 10 metre grid reference if you were using a device that was only providing a grid reference that is accurate to the nearest 50 metres. Likewise, recorders should only record organisms to a taxonomic level they are comfortable with. Within a single record, some of the components of the record may be of a high resolution, while others are of a low resolution. We will now explore an example of a recorder that observed a ladybird in her garden. The observation occurred during 2016 and was submitted anonymously to the Friends of Darwin Close group to the nearest 10 km grid square. This is a low resolution record and has very limited use. Different species of ladybird have different ecology and behaviour, and the spatial and temporal data is not precise enough to do much in the way of analysis. Furthermore, without details of the actual recorder, it is difficult to find out more about the record. We can increase the resolution by adding in the recorder name, narrowing down the identification to genus level, increasing the geographic precision to a 1 km by 1 km grid square, and specifying the month when the observation occurred. This makes the record more useful to scientists, conservationists, and decision makers. However, we can increase the record resolution even further by providing context about the people involved, a full species name, and narrowing down the geographic location and date even more. This increased resolution opens up the record to an even wider number of uses. In summary, biological record resolution can be increased by providing more detailed information regarding the four basic components of a record: who, what, where, and when. When establishing what resolution to record at, recorders should take into consideration any limitations that may impact the accuracy of the information that they are providing.